This is the OCR GCSE 9-1 Maths paper 4 from the June 2018 series, and this paper is a calculator paper. Question number 1, part A. The ratio 2 centimeters to 5 meters can be written in the form 1 to n. We have to find the value of n. So, we have 2 centimeters to 5 meters. We need to write this in the form 1 to n. The first thing we can do is make the units consistent. Let's convert everything to centimeters. So we have 2 centimeters to 500 centimeters. We need to write this in the form 1 to n. So what we can do is divide both sides by 2. So if I divide both sides by 2, we end up with 1 to 250, meaning n is 250. Part B, Jay, Shyla and Harry share £7,200 in the ratio 1 to 2 to 5. How much does Harry receive? So here is that ratio represented in a diagram. We've got 1 to 2 to 5. We have in total 7,200. We have 8 parts, which means each part is worth 900. So for Harry, we have 900 multiplied by 5, which is 4,500. So Harry receives £4,500. Question 2. Given that y to the 18 divided by y to the 6 is equal to y to the k, we have to find the value of k. So, we have y to the 18 divided by y to the 6, and if we work out what this is equal to, well, we would have to subtract the powers. So we have y to the 18 subtract 6, leaving us with y to the 12, meaning k is 12. Question number 3. Part A, for the first part, we have to write 120 as a product of its prime factors. So, we've got this 120, and we can split this up as 2 times by 60. 60 we can further split up as 2 times by 30, 30 we can further split up as 2 times by 15, and 15 we can further split up as 3 times by 5. Which means then 120 is equal to 2 times by 2 times by 2 times by 3 times by 5. And if we were to rewrite this, we can rewrite this as 2 cubed times by 3 times by 5. The second part of part A, the lowest common multiple of x and 120 is 360. We have to find the smallest possible value of x. So, let's find out what 360 is as a product of its prime factors. So, 360, that's equal to, well, if I type 360 into my calculator, then shift, and then this button, we'll find 360 is equal to 2 cubed, which I'm going to write as 2 times 2 times by 2 times by 3 squared, that's 3 times by 3 times by 5. So that's what 360 is. Now, the lowest common multiple of x and 120 is 360. Now, the best way to represent this is actually using a Venn diagram. So here we've got a Venn diagram. We've got A, and we've got, well, here we've got the 120, and here we've got x. Now, I know what 120 is. That's shown here, and I've got altogether 360. Now, if I think about how I work out the lowest common multiple, that will be everything in the Venn diagram multiplied together. So what we mean by that is this bit altogether is 360, which is 2 times by 2 times by 2 times by 3 times by 3 times by 5. That is what 360 is. So if I compare this to what we have here, well, essentially we've got the 2's which are the same over here. We've also got a 3 which is the same, and we've also got a 5 which is the same. And what's left over is this 3 here. Okay. Now, the way to think about this is altogether we want this entire build-up to be 2 times 2 times 2 times 3 times 3 times 5. And we already know what 120 is, that's shown here. So, we would have the 120, which we can put in as 2 times 2 times 2. But remember, 120 is 2 times 2 times 2 times 3 times 5. So, the 5 will also go here. And I can have this 3, which is common, going here. So I've got 2 cubed times 3 times 5, so this is the 120. And then I can put this 3 here, which means x is 3 times by 3. So x equals 3 multiplied by 3, which is 9. So the smallest value of x is 9. Two numbers, a and b, are written as the product of prime factors. A is equal to 2 to the 4 times 3 squared times 7 squared, and b is equal to 2 cubed times 3 times 5 times 7. We have to find the highest common factor of a and b. So let's use a Venn diagram for this. So we've got a and b. So let's think about what's common. Well, here I've got a 2 to the 4, and here I've got a 2 to the 3. So the biggest number of both of these is 2 cubed. Here I've got a 3 squared, and here I've got a 3, so the biggest number from both of them is 3. Here I've got a 7 squared, and here I've got a 7, so here I've got 7 here. So what's left over for a, I've got 2, and then I've also got a 3, and I've also got a 7, and for b, I have a 5 here. Which means the highest common factor is 2 cubed times by 3 times by 7. So if I work out what this is, I end up with 168. Question number 4. Lee wishes to find out if there is a relationship between a person's age and the time it takes them to complete a puzzle. Lee decides to conduct an experiment. She asks 12 people to complete the puzzle. She records each person's age and the time taken to complete the puzzle. Part A. Make one criticism of Lee's method. Well, quite simply, Lee's sample size is too small. They could ask more people to get a more accurate representation. Part B, this scatter diagram shows the results for 10 of the people in Lee's experiment. Here are the other two results, so we've got the age and years. Plot these results on the scatter diagram. So we've got 4721, so plotting that goes here. And then we've got 6034, so that goes here. We've plotted the results on the scatter diagram. Part C, what type of correlation is shown in the scatter diagram? Well, generally speaking, as the age increases, so does the time, so we have a positive correlation. Part D, estimate the time it would take a person aged 35 to complete the puzzle. Show your working to justify your answer. For this, we need a line of best fit, and a line of best fit has roughly the same amount of points above the line as it does below the line. So, our line of best fit looks something like this. So if I draw a line up from 35 and then read across, you can see here we have 11. So it takes 11 seconds. Part E, Lee says that at least 80% of the 12 people completed the puzzle in under 30 seconds. Is Lee correct? Show working to support your answer. Well, how many completed the puzzle under 30 seconds? So 30 seconds is here, so the number of people is 1, 2, 3, 4, 5, 6, 7, 8, 9. So therefore, we have 9 over 12 people, and if I multiply this by 100, we get 75%. Now clearly, this is less than the 80%, which is what Lee is suggesting. So is Lee correct? Well, we can conclude Lee is incorrect. Question number 5. The scale diagram below shows two cities, P and Q. And we've got the scale 1 centimetre represents 125 kilometres. The plane departs from P at 9:47 and arrives at Q at 12:07. Part A, we have to work out the average speed in kilometres per hour of the plane. If we measure the distance from P to Q, what you will find is we end up with 11.5 centimetres. And what we can do is use this scale to help find the actual distance. So the actual distance is equal to this 11.5 multiplied by 125. So if I work out what this is equal to, we end up with 1437.5. Actual distance then is 1437.5 kilometers. Now what we can do is find out the time from P to Q. So the time from P to Q, well, we've got 12:07 PM subtract 9:47 AM, and if I work out what this is equal to, I end up with 2 hours and 20 minutes. So we have 2 and 1/3 of an hour. So to work out the average speed, we have this 1437.5 kilometers divided by the 2 and 1/3 hours. So let's work out what this is equal to. If I divide this by 2 and 1/3, we get 616.07 etc. kilometers per hour. Part B. Give one reason why your answer may be inaccurate. Well, quite simply, the plane may not have flown in a straight line. Question number 6. Triangles A and B are drawn on a coordinate grid. That's what we see here. For part A, we have to describe fully the single transformation that maps triangle A onto triangle B. Well, A to B, you can see we've got this line y equals x, and essentially this is our mirror line. So the transformation that maps A to B is a reflection in the line y equals x. Part B, triangle A can also be mapped onto triangle B by using a combination of two transformations. A transformation T followed by a reflection in the line x equals 0. We have to describe fully transformation T. Well, to do this question, what we have to do is work backwards. So, for us to work backwards, let's start off with this reflection in the line x equals 0. Here's the line x equals 0, and if I reflect B, we have B dash. So essentially we go from A to B by going first from A to B dash and then to B. So how do I go from A to B dash? That's going to be the transformation T. And that is a rotation 90 degrees clockwise about the origin. Question number 7. The scale diagram below shows towns A, B and C. Line AB represents the road from A to B, and the line AC represents the road from A to C. A shopping centre is to be built so that it is nearer to the road from A to B than the road from A to C, less than 14 kilometers from town C. Part A. Using construction, shade the region where the shopping centre could be built. Show all your construction lines. And we've got this diagram, and we've also got a scale of 1 centimetre represents 2 kilometers. Now, the first thing we need to do is recognise that if it's closer to AB than AC, we need a perpendicular bisector of this angle. So the first thing is put the pointy bit of your compass on the point A, and then you need to draw an arc like so through AB, and another arc through AC. What you now need to do is put the pointy bit of your compass on the intersection point, and then draw an arc like so, maintaining the same radius. Pointy bit on the other intersection, draw another arc like so. Then you need to join this point to this intersection. Let's draw a full straight line like so. Now we've got the scale 1 centimetre represents 2 kilometers, and we know that it's less than 14 kilometers from town C, and the 14 kilometers using the scale will be 7 centimeters. So we need to draw a radius of 7 centimeters from the point C. So if we measure out 7 centimeters, like so. Point a bit here, and then draw an arc, like so. So we want it to be closer to AB than AC, so that's above this line, and then we want it to be less than 14 kilometers from Townsea, so the required region is as follows. Shown here. Now, we have to explain why the region found in Part A may not be an appropriate site for the shopping centre. Quite simply, roads A, B and AC may not be straight lines. Question 8. A, B, C and D are points on the circumference of a circle with centre O. The angle CAD is 28 degrees and CD is 6.4 centimeters. BD is a diameter of the circle. We have to calculate the area of the circle. Well, the first thing we can state is BCD, so that's this angle here. That's 90 degrees because the angle at the circumference in a semicircle is 90 degrees. So let's show that here. Then we can find out the angle CBD, which is the same as the angle CAD, which is 28 degrees. The reason for that is angles in the same segment are equal. So we've got this 28 here. Now what we can do to find the area of a circle is find the radius. Now here we've got the longest side, which is the hypotenuse. We've got a right angle triangle, we've got the opposite, and we've got this given angle, so we need to use sine. So with our opposite being 6.4 centimeters, sine 28 is equal to 6.4 divided by BD. So if I rearrange for BD, BD is equal to 6.4 divided by the sine of 28. And if I work this out, I get 13.63, etc. So now that's what the diameter is, so I need to find the radius by dividing by 2. So the radius is 6.816, etc. centimeters. So for me to work out the area is equal to pi multiplied by radius squared, so multiply pi by 6.816, etc. squared. And if I work this out, we get 145.9, etc. centimeters squared. Question number 9. The dimensions in centimeters of this rectangle are shown as algebraic expressions. We have to work out the length and the width of the rectangle. Now what we know is that the opposite sides of a rectangle are equal. So we have 5x subtract y subtract 8, which is equal to 3x plus 5y plus 4. And if I simplify this, you will find x subtract 3y to equal 6. Let's call this equation 1. Similarly, we have the 3x plus y subtract 4, which is equal to 2x subtract 6y subtract 3. And if I simplify this, you will find x plus 7y to equal 1. Let's call this equation 2. Now, I've got two unknowns, x and y, and I've got two equations, equation 1 and equation 2. I can use this to find out what x and y are, and from that find the length and the width. So, if I do equation 2 subtract equation 1, 7y subtract negative 3y, that's 10y, 1 subtract 6, that's negative 5. 10y is negative 5, and if I solve for y equals negative 0.5. I can use this to find out what x is. So if I substitute into the second equation, I have x plus 7y, so I've got 7 multiplied by negative 0.5, and this is equal to 1. So I've got x subtract 3.5, which is equal to 1, which means x is equal to 4.5. Now, I've got the length and I've also got the width. So, for me to work out the length, that's equal to, well, I've got 3x plus 5y plus 4, so I've got 3 multiplied by 4.5 plus 5y, so that's 5 multiplied by negative 0.5 plus 4, and if I work out what this is equal to, I get 15. And if I work out the width, the width is equal to 3x plus y subtract 4, so I'll have 3 multiplied by 4.5 plus negative 0.5 subtract 4, and it turns out I get 9. The length is 15, the width is 9. Question number 10. 60% of people in a town are males, 20% of the males are left-handed, 21.6% of all the people are left-handed. We have to work out the percentage of the people who are not male who are left-handed. So, to do this question, we would have to construct a two-way table. So let's think about the information we've been given so far. The total number of males we have is 60%. That's what's told to us in the question. So we have the total for males being 60. We are then told 20% of the males are left-handed. So males left-handed will be 20% of 60, so we have 0.2 times 60, which is 12. So we have 12% who are males. Then we have 21.6 of all the people who are left-handed. So we have 21.6 for the total number of people who are left-handed. What we are required to do is find out those who are not male who are left-handed. So we know in total we would have 100%. So the total number of females will be 40. The total number of right-handed 100 take away 21.6, that's 78.4. And then what we can see from here then is not male, that's going to be 40, and then not male left-handed, that's going to be this category here. So 21.6 take away 12, that's 9.6. And if we finish off the rest of the two-way table, here we'd have 48, and here we'd have 30.4. So therefore, we have 9.6 divided by 40 multiplied by 100. So if I work this out, we get 24%. Question number 11. Y is directly proportional to the square of x. Find the percentage increase in y when x is increased by 15%. So, we know that y is directly proportional to the square of x, meaning y equals k x squared. And we know that x is increased by 15%, which means that this new x value is equal to 1.15 x. So, if I replace the x with 1.15x, our new y value is equal to k, some constant, multiplied by 1.5x squared. So I've got k multiplied by, now here I've got 1.15 squared, which is 1.3225 x squared. So when I come to find out my percentage increase, that would correspond to 32.25%. Question number 12. The value of a car V pounds is given by V equals 16,500 multiplied by 0.82 to the n, where n is the number of years after it is bought from you. Part A, write down the value of the car when it is new. When it is new, n is equal to 0. So we have 16,500 multiplied by 0.82 to the power of 0, which is 16,500. So the value of the car when it's new is 16,500. Part B, write down the annual percentage decrease in the value of the car. Well, we've got this 0.82. So, as a multiplier, we would have 1 subtract 0.82, which is equal to 0.18. And therefore, as a percentage, we would have 18%. Part C, show that the value of the car after 4 years is less than half of its value when new. So let's work out the value when new and half that. 16,500 divided by 2, that's equal to 8,250. So, after 4 years, that's when n is 4, we have the value, which is equal to 16,500 multiplied by 0.82 to the power of 4. So if I work this out, we have 16,500 multiplied by 0.82 to the power of 4, and it turns out we get 7,460.01, and therefore the 7,460.01, that is less than the 82,550, hence shown. Question number 13. A menu has 6 starters, 10 main dishes and 7 desserts. Part A, a 3-course meal consists of a starter, a main dish and a dessert. How many different 3-course meals are possible? So, we've got 6 starters. We have 10 main dishes. And then we've got 7 desserts. And if I multiply these together, that tells me how many different combinations are possible. And it turns out we get 420. Part B, a 2-course meal consists either of a starter with a main dish, a starter with a dessert, or a main dish with a dessert. Show that there are 172 possible different 2-course meals. So, we've got this starter and the main. We also have a starter and a dessert, and we also have a main with a dessert. And if I multiply these and add them together, what we have is 60 plus 42 plus 70, and it turns out we get 172. Question number 14. The Venn diagram shows the number of students studying mathematics and the number of students studying physics in a college. 35 students do not study either subject. Part A, the total number of students is 121. We have to find the value of x. So, we've got 41 plus x plus 18 plus 35. This is equal to 121. So I've got 41 plus 18 plus 35, which is 94. So if I do 121 take away 94, I get 27. So x is equal to 27. So what we'll do then is we'll add together this 27 to the Venn diagram. Part B, one of the 121 students is selected at random. We have to find the probability that the student studies maths given that they study physics. So how many study physics? The number of students who study physics, that's equal to the 27 plus this 18. So physics is equal to 27 plus 18. So if I work out what this is equal to, we get 45. So the probability of maths given physics, that's equal to, well, we've got 27 who study maths and physics, that's what x is. Divided by 45, and if I work out what this is, I would end up with 3/5. Question number 15, part A, write x squared subtract 8x plus 25 in the form x subtract a all squared plus b. So, what this is equal to, well, what we'd have to do here is complete the square. So I'll have x subtract 4 squared subtract the square of 4 plus 25. So I have x subtract 4 squared subtract 16 plus 25. So I end up with x subtract 4 squared plus 9. Part B, write down the coordinates of the turning point of the graph of y equals x squared subtract 8x plus 25. Well, the x coordinate will be the opposite of -4, which is 4, and the y coordinate will simply be 9. Part C, hence describe the single transformation which maps the graph of y equals x squared onto the graph y equals x squared subtract 8x plus 25. Here we have a translation by vector 4, 9. Question number 16, solve by factorization 3x squared plus 11x subtract 20 equals 0. So what we require here are two numbers which multiply to give 3 times -20, which is -60, and which add to give 11. What you will find is those two numbers are 15 and -4. So we can rewrite this quadratic as 3x squared plus 15x subtract 4x subtract 20, and this is all equal to 0. So we can split this down the middle, and if we do that, we can rewrite this 3x squared plus 15x as 3x multiplied by x plus 5. We want an x plus 5 here as well. We multiply x by plus 5 by to get -4x subtract 20 is -4. And all of this is equal to 0. So if I factorize by grouping this 3x and this negative 4, what we have is 3x subtract 4 multiplied by x plus 5 equals 0. So we have 3x subtract 4 equals 0, in which case x is equal to 4 over 3, or we have x plus 5 is equal to 0, in which case x is equal to negative 5. Question number 17. For each graph below, select its possible equation from the list. On part A, we've got this graph here, which is the graph of y equals 1 over x. Next, we've got this graph here, which is the graph of y equals sine x, and here we've got the graph of y equals 2 to the x. Question number 18. Calculate the area of this triangle. Well, we've got three sides of length 5.8 centimeters, 3.9 centimeters, and 6.4 centimeters. Now what we need to work out the area are two sides and an angle in between. So, if I call this side A, this angle is A. If I call this side B, this angle is B. And if I call this side C, this angle is C. So we can use the cosine rule to find out the angle A. So we have A squared, so that's 6.4 squared equals B squared, so I'll have 3.9 squared plus C squared. So we add on 5.8 squared, subtract 2 times by B, which is 3.9, times by C, which is 5.8, multiplied by the cosine of A. So what we need to do is rearrange for cosine A. So cos A is equal to 3.9 squared plus 5.8 squared, subtract 6.4 squared, divided by 2 times by 3.9 times by 5.8. So let's work out what this is equal to. So I've got 3.9 squared plus 5.8 squared, subtract 6.4 squared, divided by 2 times 3.9 times 5.8. So we get 0.1744, etc. Which means the angle A is equal to the inverse cosine of this, which is equal to 79.95, etc. degrees. So therefore, to work out the area, that's equal to 1/2 times by 3.9 times by 5.8 multiplied by the sine of 79.95, etc. So let's work this out. got a half times 3.9 times 5.8 times the angle, and it turns out 11.13 etc. centimeters squared. Question number 19. Here are the first four terms of a quadratic sequence: 0, 9, 22 and 39. The nth term can be written as an squared plus bn plus c. We have to find the values of a, b and c. The first thing we can do is find out the difference between each of these terms. Difference between 0 and 9 is plus 9. Difference between 9 and 22, that's plus 13. Difference between 22 and 39, that's 17. We now need to find the second difference, that is the difference of these differences. Difference between 9 and 13 is 4. Difference between 13 and 17, that's 4. Now to find the value of a, we need to take this difference and divide it by 2. So 4 divided by 2 is 2, meaning a is 2. Now if I write the n squared terms out, that's just the square numbers. We've got 1, 4, 9 and 16. Now because I've got a 2 over here, I now need to work out 2n squared, so I need to multiply these by 2. 1 times 2 is 2, 4 times 2 is 8, 9 times 2 is 18, 16 times 2 is 32. If I write out my original sequence, I've got 0, 9, 22 and 39. And now if I do sequence minus 2n squared, 0 subtract 2 is negative 2, 9 subtract 8 is 1, 22 subtract 18 is 4, 39 take away 32 is 7. We now have a linear sequence and we can find the nth term of that linear sequence. Difference between negative 2 and 1 is 3, difference between 1 and 4 is 3, difference between 4 and 7 is 3. Now to find the 0th term I need to do the inverse of plus 3, which is negative 3. Negative 2 subtract 3 is negative 5. So for our nth term we have 2n squared plus 3n subtract 5. So a is 2, b is 3 and c is negative 5. Question number 20. Solve this equation giving an answer correct to one decimal place. We have 5 over x plus 2 plus 3 over x subtract 3 equals 2. Now if I have this 5 over x plus 2, I can multiply both the numerator and the denominator by x subtract 3. This is an equivalent fraction to this. And then I add on 3 over x subtract 3. And if I multiply both the numerator and the denominator by x plus 2, we end up with this result here, which is equivalent to this. And this is equal to 2. So I've got 5 multiplied by x subtract 3 plus 3 multiplied by x plus 2 all over x plus 2 multiplied by x subtract 3 equals 2. I'll now need to find out what x is. So I've got 5 times by x, which is 5x, 5 times negative 3, which is negative 15, 3 times x, which is 3x, 3 times 2, which is 6, and divide this by x plus 2 times x subtract 3, and this is equal to 2. So on the top I've got 5x plus 3x, which is 8x, negative 15 plus 6, which is negative 9, and I set this equal to 2 multiplied by x plus 2 times x subtract 3. So the left hand side is going to remain the same as 8x subtract 9. On the right hand side I've got 2 lots of, now if I multiply this bracket, x times x is x squared, x times negative 3 plus 2 times by x, that's negative x, 2 times negative 3, that's negative 6. So if I expand on the right hand side, I've got 2x squared subtract 2x subtract 6. And if I simplify all this, I have 2x squared subtract 10x subtract 3 equals 0. So a is 2, b is negative 10, and c is negative 3. So let's substitute this into the quadratic formula. I've got x equals negative 10 plus minus the square root of negative 10 squared subtract 4 times by 2 times by negative 3 all over 2 times by 2. So let's find out what x is. I've got negative 10 plus the square root of negative 10 squared, subtract 4 times 2 times negative 3 over 2 times 2. So I end up with one x value as 5.3, and for the second x value we change this to a minus, and we end up with negative 0.3. So these solutions are to one decimal place.